Hello Precalculus student, this video is for chapter 4.1, Exponential Functions. Exponential function can be used to model change of some value over time or primarily over time. You can depends on anything x also. So the change occur like this as compared to linear function. Linear function can be models things that had a constant amount of change over the same increment of input x or same time. So if your times increase in a constant way, you have the same amount of increase, basically the same rate of change, then it's a linear function. For example, I can have time 0, 1, 2. So to model a linear function, I can say, okay, in the beginning, I have y equal to 4. Then I increase by 1, 5. Increase by 1, 6. So that is linear. A constant plus 1, right? Plus 1, constant increase. But exponential function would be not a constant amount of increase, but a constant percentage of change. So it's the percentage. So 0, 1, 2. So if I say y equal to 4 in the beginning, and the percentage rate is at 25%. So that means based on what you have, you add 25%. So what is 25% of 4? It's 1, right? So you add 1, so it becomes 5, right? You add whatever that you have. And then you add 25%. So what is 25% of 5? 25% of 25% of 5 is 5 times 0.25 is 1.25. So you would have 6.25, right? It's at 25%. So it's constant percentage change. It's adding to it. So this one is exponential. This is linear. This is exponential. And you can also, instead of looking at percentage change, you can say, instead of adding, I'm multiplying. So ty, so if I have 0, 1, 2, but in the beginning I have 4, I want to times 1.25 for the second one. So 4 times 1.25 would be 5, right? 5 times 1.25 to get to the next one would be, so 1.25 times 5 would be 6.25, right? So I have a constant multiplicative factor. So I multiply a same number to get to the second one. That is exponential. And you can see this actually, these two are the same. A constant rate of increase, constant percentage of increase is the same as a constant multiplicative factor. Both of these are exponential, but if you constant add a number, not multiplying, not percent, then it's linear. Okay, so look at this example. See, I have three statements and 3 tables, so we have to identify if they are linear, exponential, or neither. The population of a city decreased 0.3%. So this is a constant percent, but it decrease and increase are both exponential. So long as the change is a constant percentage, so I know it's exponential. So kind of like instead of adding 25, I decrease 0.3%. So this is exponential, not linear. B, the radius grow by a factor of 1.2. So it's always multiply the same 1.2 factor, just like we multiply 1.25. So that is also exponential. The keyword is constant percent or constant multiply constant factor. C, the saving increase $100 per month. That is linear, right? It's a constant every month. Constant rate of change. That's linear. So now we have table now. So we have to figure out if we have a constant of increase, decrease, or a multiplicative factor. So obviously you can see plus 5. These are same increment, right? Plus 5 to go to the second one, plus 5. So linear, right? The rate of change, constant rate of change is linear. So when you look at the graph, it's like a line. Whereas for exponential, if it's growth, it would be growing like this, right? Shoot up quickly. So is this a constant add? Oh no, constant decrease. So 70 minus 49 up to minus 21, right? Minus 21. But from 49 to 34.3, you can tell that it's not. It's minus 20, minus 21. This is minus 14, so it's not constant add or subtract. Is it a constant multiple? 49 over 70 is what? It's 0.7. That means if I multiply 0.7, I got to 49. What about 34.3 over 49? 34.3 over 49 is also 0.7. So there is a constant multiplicative factor. We can also check 24 over 34.3 is also almost 0.7, right? So this is times 0.07 is a constant multiplicative factor, so it's exponential. And it's getting less and less, so it is not exponential growth, it's an exponential decline. What about this? If I do minus, if I do add, it's add 3, add 4, so it's not linear. So do I have a same multiplicative factor? 8 over 5 is 1.6, but 12 over 4 is what? 12 divided by 4 is 3. No, divided by 8. 12 divided by 8 is 1.5. So it is not a constant factor. It's not a constant add, so it's neither. Okay, so that's how you identify if a description or a table values can be modeled by exponential. Now, out of exponential, there are two different types, as you can see. Just like linear, you can have increase or decrease. Exponential function also had growth or decay. Growth means increasing, decay means decreasing. So, and also, what is the form of an exponential function? For linear function is y equal to mx plus b. It's a line. But for exponential function, the general form is ab to the power x. Now remember, so for order of operation, the x goes to b only, right? So when we say abx, the exponent is applied to b. As a matter of fact, when we evaluate a function, we evaluate b to the x first and then multiply a. If you have a scientific calculator, if you put in a, b, x in this sequence in the calculator, they know to do b of x first before they multiply a. Now, a, b, x has also special meaning. What is a? A is actually the initial value. So this is a value kind of like the y-intercept when x is 0. When x is 0, you start off with a. And b is the multiplicative factor that we talked about. So in the last example, we see, oh, I keep on multiply 0.7 to get to the second one. That 0.7 is b, whatever that you multiply. So must be a positive number, because if you multiply a negative number like the one and then the second, you will switch between positive and negative. Doesn't make sense. So b as a base in an exponential function can only allow b being positive, except of course 1, because if it's 1, then it's a constant function. When b is greater than 1, that means you multiply 1.2, 1.25, like what we did earlier, is your a keep on growing, right? Whatever that you have for y, a would multiply by a number that is greater than 1 that's growing. If b is between 0 and 1, which is a fraction, then it's a decay function. So just imagine if you have a starting number like 4 or whatever, you multiply by a fraction, it's going to decrease. And remember, b is the multiplicative factor. So later on, I'll talk about where is this constant percentage rate. So we'll talk about that later. So because it's a function, we always talks about the domain, right? So what can I plug into x? In general, if it is it's not modeling real life situation, x can be a real number. But if you are using this to model real life situation where x is time, then of course time has to be positive. So it depends on the situation. In general, in a abstract form, x can be anything. You can put x as just an exponent. It's just an exponent to b. And then what about a? what about range? So b is always positive because that's how we require the exponential function to be. So all this number multiplying will be positive if a is positive. So ranges are positive number if a is positive. If a is negative, that means initially you start with negative number and you multiply these positive things, it's always going to be a negative number if you start off with negative. Okay. Y-intercept. Y-intercept is when x is 0. We talk about that. That is the initial value, 0, comma a. It also has a horizontal asymptote. What is horizontal asymptote? Which is end behavior, right? So um, we will talk details about this in 4.2. But what happened is when x approaches negative infinity, y approaches 0. So you see that there is a horizontal asymptote when we're talking about a growth function, but we will talk about this in more detail. So basically, you see this function has an asymptote in one. Oh, I think is this is when b is positive. Okay, this is when b is positive. That just you can think about it. If you have b being a positive number, um, is not positive. B is a growth function. It's a growth function. Let me clear this. If B is a growth function, is getting more and more. But if you go to the negative side, then B would be you're dividing B, right? You're dividing B, keep on dividing. So the whole thing will become 0. Okay, so which is reverse, but we'll talk about those in 4.2. So with that, let's identify exponential growth or decay. So remember, it has to be a constant b base, and the input x is in the exponent. Okay. So 200, 1 minus t cubed, is it an exponential function? I see an exponent, but it is not t, not the input t. Oh, this should be f of t, right? But it's not t, so it's not, right? Neither. So this is a base 1.06 and my x is here, so it is an exponential, and the base is greater than 1, so it is a growth, right? It is exponential growth. This would be, I have b is less than 1, the x is in the exponent, so this is exponential decay. It's less than 1. I have x in the base, no, not, right? Neither. It's just a polynomial function. And this I have a base, but I have 1 over t, which is not t, so it's neither. So the exponential function is x has to be abx. B is greater than 1 or less than 1. So how do I relate the growth rate? B is the growth rate R. Okay, so we talk about it as a constant percentage of increase, growth rate, or this is not growth rate, it's a decay rate. I have some typo, I'll correct it. So how do I do that? So actually the relationship is B is equal to 1 plus R if it's a growth, and B is equal to 1 minus R if it is a decay. So look back at the very beginning when I talk about this. The growth rate is 25%, so that's why my B is 1.25, right? It's 1 at 25. So this 25 decimal number after the 1 is the constant percentage change, percentage increase. I increase by 1, which is 25% of 4. I increase by 1.25, which is 25 of 5, right? Like that. So just remember, B is equal to 1 plus R for growth, B equal to 1 minus R for decay. So if you look at the B value, you can figure out the percentage, constant percentage. For percentage is adding. Okay. Determine if initial value. Oh, find the exponential function given 2 points. So if I have 2 points, I want to find AB.